Hi, welcome to the webinar. Our topic today is on machine probing. My name is Ann, and I'm happy to introduce our presenters. We have David Lindeman, applications engineer, has over 30 years experience working with molds and dies. We also have Ralph Piccolo, director of sales with Cimatron for over 25 years and has lots of industry experience. Now, just a little housekeeping before we begin. We encourage you to ask questions as we go. Post them in the chat window. We'll pause during and after the presentation to respond to your questions. And if you like what you see today and would like to be contacted by a Cimatron representative, hit the link, the Cimatron contact link in the chat window, leave your details, and we will be in touch. All right, let's turn our attention to Ralph Piccolo.
Thanks, Ann. Cimatron is a dedicated CAD/CAM software for the design and manufacturing of tooling. What we have done is we looked into what the designers and the manufacturers do on a daily basis, day in and day out, and provide functionality to streamline the process to increase productivity. Yes, most CAD/CAM software can do the job, but with Cimatron and the automation, we can shorten delivery times and drastically save you time and money. As we can see in the mold manufacturing industry today, the complexity is much higher, the delivery times are shorter, machine downtime is a waste of money, the human errors are costly, part handling through the shop is a pain. Automation is key, and with in-process measuring and on-machine inspection, we are addressing these items to meet the demands of the industry. This can take your process to the next level and increase profitability and customer satisfaction. Dave will show you how we address these concerns and automate your manufacturing without any human interaction. Dave, let's see how we become more productive.
Thank you, Ralph. So as we go through our example here, you'll pay attention to those blue lines. Those are the motions of the probe that we'll be talking about. So we're going to go step by step. We're going to look at each one of them so you understand how it was programmed, what it looks like, and what the results are that we're hoping to achieve. We want to be able to pick this part up or set it up, however term you like. So we have our absolute good work position, and then we're going to cut it. We're going to use our probe again to make sure our cut's accurate, and then we're going to adjust it so that we can dial it in exactly where we need it. So as we go through, you'll notice on the left, that's what it looks like programmed in Cimatron. The middle is our simulation. You can see the motions, and then the G code on the right. And simply here, I'm just going to touch a point for the Z, and we're going to program that for G55. And now we'll come along the front. 2 probe touches here to see if there's any angle in our setup. And then we'll come along both sides and then go front to back. I picked G55 as my work offset, could be whatever you prefer to work with. So now going forward, then let's look at that on the machine. So as you watch the controller, you'll see in our work offset page, we zeroed out G55. And as the probe does its thing, you'll see how it's putting that information into that work offset. So very quickly, we can pick up a much more accurate pickup than normally we would using the conventional tools that we may have. And then we'll come across again here to the opposite side. And you can imagine how you do it now. Perhaps you use an edge finder to come along an edge and try to zero it out there, then dial it over. You're bringing your tool down to get your tool offset. You may be wiggling a piece of paper or a piece of shim stock underneath it until it traps it. Then you know you've got your tool offset. Very accurately here, we're using the probe to get that information. Now our G55 is ready for us to take our cut with. Okay, so going back to our, we want a 5-axis example now. Of course, with the 5-axis example, there's a lot more involved than the previous part you just saw. So we're just going to let the simulation play so that you can see what's happening and we're not getting lost in any of the flips and the turns that the machine will make. So we're using the same cycles that we did before with the 3-axis, just more of them. We need to get a couple more angles than we did before. We also need to make sure that we're getting our sides so that we get the dead center. Again, we're going to try to work from top center. That's our preferred option, my choice, programmer's choice, whatever it may be. And you can see how it's going to go through those cycles to get the information that we need. Now, you can imagine, again, the work that goes into just picking the part up or getting your setup. A lot of times I may have to use an indicator to dial in a dowel position to get my zero that way. And all that work gets lost if I ever have to take the part off the machine, right? So maybe I take the part off, inspect it, put the part back. I'll have to go through all those steps again to pick the part back up. What's important here is that the part does not leave the machine. That way I know that everything I have is good to go from here on out. Let's go back to our example here. We've got the pickup done, the setup. Now we're going to take a profile cut. We're going to use the probe to get the measurements, and then we'll cut it again. Okay, so here you see it stepping through, getting the profile cut that we need. It'll go around, and then we'll be able to take our measurement. So if we advance forward here, there we go. Now, as I'm cutting, you'll notice on the left side, I'm saying do it with tool compensation on, and I'm leaving 5/1000ths of stock. And that's pretty much standard for what we want to do. Now we'll go ahead with our probe. We'll take our measurement here. And that's going to be a ridge width cycle. And what that does now is it takes this measurement and it's going to affect the tool offset. In this case, the wear offset. We'll find the difference of what has been cut to what we need. And then finally, we'll go back and use that information now to adjust our actual cut. So deflection, tool wear, we may not understand what those things are. We know we're going to recut it, so let's leave enough material so that we get a good recut. That's why we'll leave the 5/1000ths. We'll take that in addition to whatever deflection may have occurred. So again, the proof is on the machine. Let's go to the machine. We'll continue this program here. It starts from G55, just like we asked. And now it's going to go around taking that cut. You'll notice the offsets and the positions of flash we highlighted on the controller for you so that you can see right when it's doing the work that it's doing. Now, as we come back with the probe, the information we get is going to appear on your lower right of your controller screen. It's going to populate in label 1. And that will be what we use then as we make the adjustment to the cut. You don't see my hand in this picture. Right? So it is all being done without any manual input, which means I saved myself from typing a wrong number. And it's accurately measuring it for me and making that adjustment now. So very quickly, very, very easily, we can accomplish this. And we know we're good before we send this part off to any other further manufacturing processes. And then maybe standard practice, if you so desire, is to go back and measure it again and just prove to yourself that it's actually done what you need it to do. Okay. Finally, you see the measurement. Again, you can compare that to know exactly where you're at. Taking this further then, if we go forward with our 5-axis example, we're just going to do an inside cut along the trench of that part, and then we'll measure it, cut it again. And I just can't stress how important it is that I'm not taking this part off the machine to make that measurement, because the work it would take to put it back up would be so much time. And what if I didn't get it right? You can understand there'd be a big problem. I would scrap out this part. Maybe I'm doing some production, and every so often I'll take my calipers and I'll measure across, that slot to see if I'm hitting my numbers. I may go 5, 6 parts, and then finally I measure one and I realize, oh, I'm out now. I may have made 5 or 6 parts of scrap. Here with each part, I can quickly just do my measurement, see it on the machine. If I need to make the adjustment, I'm good. and I can keep right on going and eliminate that expensive scrap. Okay, so we threw a lot at you here in a few minutes. Let's see if anybody has any questions.
Yes, please post your questions in the chat window.
You know, Dave, one of the questions that I often get when I'm, talking about this to customers and prospects, basically they want to know which probes are supported. Most of the probes, they use the same cycle calls for their, ridge widths and their point selection. We do support the Renishaw, the Marpos, the Heidenhain, the Haas, and the Bloom. All of those have very similar cycles. So those are, those are the ones that we've seen now. And I'm sure any of the others that are out there, we can support them because they're very similar on their cycle calls. Yeah, we will have to do some post editing to modify it. And a lot depends on your control. And a lot depends on, the version of the control as well, too. But there is some work to be done, but we can accomplish to do this all unattended. So,
Okay, very good.
Okay, great. Again, post your questions in the chat window, and we will respond. Well, it looks like we can proceed with the presentation. David?
Okay. We'll look at a couple more examples here. So we selected a mold plate that we're going to work with as our first example. And all I'm going to do is just use a simple little point cycle to come along and tap on the part, use my probe to identify the points that I want to check. Okay, so very simply, you can see I'm just moving across, getting those points that I want to inspect. It knows the direction for me, knows the normal, so it's going to set up the approach. All that information can be whatever I specify it to be. And then from there, it's going to take those points, and we'll be able to create the code that we're going to send to the controller. Now, maybe as I'm looking at this, I want to do a quick little double check on it and visualize that I've got these in the right sequence. We have a nice little on-the-fly simulator here. We call it the Navigator. It just lets us walk through it. I can see I'm doing the top first and then the sides. So it all just makes sense to me. I like it. We'll post it. Now, as we post it, we're going to pick the machine that we want to send it to, obviously. And there could be multiple machines that we're working with. All of these posts are customized to that machine so that there is zero manual editing. And as the G code pops up here, I don't have to go in there and change any of my startup lines or anything like that. So that code is good to go to my Haas, and we'll send it over, and we'll use the probe on the machine to get those points. So you can imagine here in the interim, I've gone forward, brought my probe down. We're going to actually go ahead, harvest those points, and now we're going to bring that information from the controller over here into Cimatron. That could be something as simple as I did a text formatted file or something that's specific to whatever your controller is. Okay. Now we'll take these points. It's going to tell me, read it in. Great. I know how many. And then let's do the comparison. So here's where it really starts to get interesting. So if it's in green, then it's within my tolerance. If it's red, then it's a condition where I have overcut it. If you're to see blue, then you'd know there's still some remaining material. There's a nice interaction between the points on the chart and then the surface. You see, tap that point, surface highlights, it makes it really easy to identify that area. Right away, I can tell there is a problem here. I've overcut the top somehow. How did that happen? So now I've got enough knowledge I can begin making some decisions without having to take the part off the machine. From here, maybe I'm going to generate my Excel spreadsheet. Again, you could customize Excel to whatever works best, and I can propagate that information to others. They can look at it together. We can make the decision. What happened? Did the tool offset? Was it wrong? Do I need to maybe drop and remachine? What are we going to do so we can still use this mold plate? So that's valuable information while I'm on the fly in my process and not having to set that back up after taking points. Let's look at another example, and this is something that mold makers will do day in, day out. That's work with an electrode. So I've got multiple electrodes within this particular job, and I'm going to pick the one that I want to work with. And this is a tease. Cimatron has a great solution for electrodes that we hope we can show you someday as well. I've picked a two-sided electrode that I'd use to burn the mold shutoffs. Okay, so it's going to be fine for us gathering some points and doing some inspection. Within our EDM setup, we specify what machine is going to do the burning and what is unique about that machine. Is it a 2D orbit, a 3D orbit? Is it just, do I just need to program the spark gap, that offset value? Am I going to affect the way I burn it? How many rough trodes? How many finished trodes? Do I want to rough everything first and then come back and finish everything? So the run order. All that information is contained in our EDM setup, and then from there, that information will propagate down throughout the rest of the process. And as you note here, as I go into NC, I'm just saying, give me my rough electrode. That's what I want to cut. So all the information, the spark gap, the overburn, all that is automatically loaded, and it's treating it as a different electrode than the finish electrode. Digging a little deeper, let's find that information further. We go into one of our sequences. There's my 5,000 spark gap. So I have not mistyped anything along the way. The whole process is contained and easily identified for me, right? So same thing, inspection points. We've got it back from the controller. Let's now do our comparison. And this is where it's a little different with an electrode. And the value of this too is, I just can't state this enough how important this is. Okay, so I'm going to bring in the text file and let's do the comparison of our points here. So in our chart, again, same color scheme. Red is overcut, green is good. But what's important is that the upper and lower limits of my tolerance are based on that 5,000 spark gap. All right, so I'm not doing the math, deduct 5,000ths from everything. It's doing it for me so that I know I'm right within where that finish of that trode should be dimensionally. Okay, that's really important. That saves a huge amount of time and guessing. What if it's not quite right again? I saw I overcut some areas. Am I going to have to drop everything and recut it? What do we do so that we don't have to waste that graphite? Again, I didn't take it off the machine, so I can make my adjustments here using these inspection points to get the knowledge of what's actually happening while cutting it. To improve this one step further, let's take this back to our little navigator here. Now let's bring the probe down and take a closer look at it. When we're looking at the electrode, like I said, we know that spark gap is there. It's going to be in the numbers. So as I bring the trode down and position it, you'll see that it's going to accommodate that spark gap. So I know I will always have that consistency around the part to part, whatever I need to do. I'm going to be able to take that measurement and know it's going to reflect the spark gap that I originally programmed. Okay, so a couple more examples for you. We hope that that helps further show you other ways you can use the inspection. Why is it that so many prefer Cimatron? Well, it's because of the tools that you just saw, things like being able to do these inspection points and understanding the spark gap of our electrodes, consistently keeping that throughout all the process, all the way down to inspection at NC. So what we do is do the things that our mold makers, our die makers are doing every day and help them so they can make it faster, they can be more productive, especially in the face of the fact that margins are getting narrower every day, and help them to avoid mistakes that can be costly until they take the profit out of the job. So hopefully you've appreciated what we've showed you here and found some interest. If there are any questions, let's turn our attention back to our moderator, Ann.
Yes, let's hear from you. Let's see what questions you have so far. It looks like some came in.
Yeah. Hey, Ann.
Yeah.
Just before we get to the questions,
sure.
What we're trying to show today is basically you can check your parts, adjust your tool paths without any interaction, manual interaction. This is a huge time saver from, cutting the job, thinking it's done, not realizing you had tool wear. You take it off the machine and now you got to throw it back on the machine. Basically, we're eliminating all of that. Like Dave showed, probing the electrode, right? And measuring and getting a report on the electrode. I think that electrode was programmed for 5 thousandths offset. And, because of tool wear, let's say it came out at 4.5 thousandths or 4 thousandths. At that point, you have a choice. Do you want to recut it and get it correct? Or maybe you just want to change the orbit value down to 4 thousandths in your machine. Again, we're getting accuracy on the machine before you're taking off the part. I mean, this is huge for a time saver. So let's look at some of the questions here. Brad asks, do you need a seat for this feature or just the probe seat? This program that Dave has with the probing is an NC procedure. So we like to have it with the NC software. That way you can set it up to, cut and check and then cut and check. And then you can make your adjustments on your tool paths. Now, another one from Tim. You mentioned using cutter comp when it is measured. When it measures the part before doing the final cut, will it make the adjustments in the program itself, or will it adjust the wear offset in the tool table? Yes, it's going to adjust the wear offset in the tool table. So like Dave explained, most, what we're seeing, the people that are using this, what they're doing is they're going and cutting it and they're leaving it full. If you notice, it was kind of hard to see when he measured that part, when he did the width of the part, it showed that it was 10 thousandths and 2/10. Well, it was supposed to be 10 thousandths. I know it's 2/10. Sometimes it matters, sometimes it doesn't, but it went in there and adjusted the wear. So it took the next cut at 5 thousandths 1/10 and took care of the total width being 10 thousandths 2/10 under. So that's how adjusting the wear offset automatically without typing it in or anything like that. So we got another question. After they're measuring it adjusts the tool radius difference and you need to run the program again. Automatically runs the program again. No, it doesn't. It doesn't automatically run it again. What we're doing is we're adjusting the finish cut on it. That's the best practice that we're doing on that. So let's see. Dave, you might have to answer this one. Brad, can you check and adjust multiple pockets at the same time? I know we can check multiple pockets. Dave, what do you think on this one?
If they're programmed on the same NC sequence,
that's what it sounds like.
They're going to use the same tool. The tool will have that same wear offset. So
okay.
At that perspective, you could do it. The question is, are they all the same? Do they have the exact same difference pocket to pocket to pocket?
Okay.
So that would be the risk you take, is that one is less, one is more,
Dave asks, is there a 3D cutter comp as well? Yeah, some controls support 3D cutter comp. We're still diving into that and investigating that. You might want to jump into the expo where we can get into a little bit more details on that. I have a problem with 3D offset because what happens when a cutter is contacting two surfaces at the same time and you want to do a 3D cutter comp? Which way does the 3D cutter comp go? So I think it's a mathematical problem, but it's something that we definitely can discuss and look into. We can do 3D cutter comp. We haven't implemented it in the probing. It's not available in the probing, I don't believe. But again, Dave, if you can jump into the expo and we'll have Matt Van Dam on a line there, so maybe we can do that.
Okay.
Do the machines needed added software? When you get the probe comes with the software. So yes and no. You don't need to add software, but it should come with the probe that you have. That was from Dave. This webinar will be recorded, and it will be shared after the event. That was from Rich. So,
yeah, a lot of questions.
Yeah, quite a few questions, and that looks like it. We'll give it another few seconds here to see if there's any more questions before we jump over into the expo. So, any last minute questions, just type them in.
All right, it looks like we can conclude the presentation, but we're not over yet. Ralph mentioned the expo. If you would like to hit the expo button, Ralph and David are going to be there live. They'll answer more of your questions, and you can view product videos, download the more materials, and it's a really great place to be. Also, if you would like to visit our website, it's www.cimatron.com. And as well, if you'd like to hear from a Cimatron representative, just hit the link with the contact information. It will take you over to an area. You can leave your contact info, and we will be in touch shortly. Now, we'd like to thank our presenters today, David and Ralph. Thank you very much. And
hey, Ann.
Yeah.
Looks like we got some more questions coming in after.
Oh, wow. Okay. Sorry. Go for it.
Let's see. James is asking, are you able to tip the probe in the software and probe at different angles? A lot depends on your control. We have, some of them have the ability to do 3D vectoring. Okay, some of them do not. Some of them you have to get additional macros or additional probe cycles from your probe manufacturer. But yes, we can do it at different angles. And the most accurate way is definitely to be normal to the surface that you're checking. So yes, it can be done on some. Some of them you have to get an additional cycle from the manufacturer of the probe. Brad is asking if this will work with our current post. Probably not. There is customization based on the probe that you have and based on the control and the software version that you're using. There will have to be customization done to the post. Alex was asking the same thing. Do you need post modifications to import the probing measurements back into the Cimatron? No. You don't need post modifications to bring the report back in. There is some customization that we do for you once you get this to format the report, because every control has a different style of report, and then we have to format it to bring it right back into Cimatron. That is, reading that back in is part of the in-process measuring and on-machine inspection software. So that's how that works there. Let's see what else we got. Does it work Cimatron 15 or just with the does it work with Cimatron 15 or just with the following versions? I believe it was in version 14. Dave, do you know?
That's correct. Yeah.
Okay. So yeah, it was in version 14. That's when we were first introduced it. We were still ironing out all the macros or the cycles for that. So this is why we have a good handle on what the control needs, what the post needs, and what the different versions of the probes. So now we had a real good handle on it, and we've been testing it for about a year and got all the kinks worked out. So this is why we're presenting it now. So Yes, this is an add-on feature. Yes, you need to have the in-process measuring and the on-machine inspection added to your software, and there will be post customization again, depending on the machine, the control, and the software version, and the probe that you have. So let's see. Are you able to probe stock surfaces to ensure stock is correct before cutting? Yeah, yes, we can do that. And basically, that was Dave was showing where he's setting the G55. We're probing the stock. You can set up where you could say, I want the probe to come down here, and I only want it to go this distance to look for stock. If it doesn't, then it's going to stop. It's going to air out, and it's going to let you know, hey, you don't have any stock there. So,
yeah, good. And something else besides that, you might have a rough cut, something like that. But remember, we talked about the angle. We're gonna understand if there's any misdirection, misalignment. And really, it's just a matter of how long that approaches, if it comes in contact with the stock face or not. And so you can imagine maybe something for some reason is off 5 degrees. We'll capture that, and we'll still run the NC program on it.
Yeah, so some people are that aren't using a vise or anything. They're just setting the part on there, clamping it down, and then letting the probe set the angle and everything like that. They don't indicate it in or anything like that. Again, this is part of the automation, not spending the time to indicate it in, knock it around, get it straight, pick up the edges, pick up the top. Again, let the probe do the work and let the probe set it. It doesn't matter to the tool path once we have the G55 that it's on a 2-degree angle or 3-degree angle or anything like that. So, and then one more question: how can I get a post processor? I would say, contact your salespeople on, and get them the information, the machine, the control, the probe that you're using, and then they can get with you and determine the cost. All good questions.
Yes. And I'm glad we came back and answered some more, and more came in. That's great.
So why don't we jump over to the expo where we can get into more detail and questions.
Yeah,
if
just
anybody has them.
Hit the expo button. It will take you right over there. And thank you again, David and Ralph. And thank you everyone for joining us. And please check on us again. We will be having more webinars from Cimatron. We'll definitely look into EDM creation further, especially what you can do to streamline your electrode build using EDM setup. So thanks again. Have a great day. And thank you. We can't do it without you.